So yesterday's formula was this just simple interest, and then today's compound interest. Okay, so what's the difference between simple interest and compound interest? Simple interest is that you just get paid your interest once off of the first amount. Compound interest means that you get interest, which makes it higher. Then the next time you get interest based off of the new amount. And then that goes higher, and then you get interest based off of that new amount. So do you see how it just keeps building and building? What option would make you more money? A simple interest or a compound interest? Compound. Okay, so here's the formula. It's a little bit different. P, we know that's the start. How much money you have at the start. This time, it equals the final. So our interest formula gives us interest. This formula gives us final. R, make sure you turn that percent into a decimal, right? And N is the number per year. So we talked about words. Do you remember words yesterday? Like semi-annually. How many times would you do something a year? Twice. If I say the word monthly, how many times do you do it a year? 12. Okay, and then you're also going to use this rule. Rule of 72 is just a little formula on your formula sheet. And it's going to be the time to double your money. That formula is an estimate. How long does it take you to double your money? And it's an estimate. Okay, so here's a difference between an R and an I. Okay, so let's do this. If I ever give you 2.5%, your I would be decimal, but if I ever used, your R would be decimal and your I would be just the percent. So do you see how this formula used R and this one used an I? So an I just does the interest as a whatever you have, okay? So they're both talking about the same thing, but the R changes it to the decimal. Okay, so if I asked you to explain a little bit about simple versus compound, what can we say? What do you want to say is the difference? Simple is your interest off of principal. Kind of like a one-time. And compound is you're getting interest off new amount, etc., right? Every time. So if you do monthly, you're going to get interest on the first month. Then on the second month, you're going to get interest based on the new amount that you have. Then the new amount, then the new amount. Okay, so here we go. Let's compare. You have a $4,000 investment, 7 years, 2.8% interest. So we're going to do a simple interest, okay? So here we go. I equals PRT. Yesterday's stuff. $4,000 is your principal. Rate is 0.028 for 7 years. So you get $784. We're matching. Okay, so what is the final? How much money do you have after 7 years? What is in your account at this point? Obviously, we're going to add, right? Because you started already with 4,000, and then you made more money. Okay, now determine if we're going to compound this annually. So this means at the end of year 1, I'm going to get a little bit of interest. Then on the year 2, I'm going to make interest off of a new amount, So using this formula. Final amount, A equals 4,000, 1 plus 0.028 divided by N. How many times a year do we activate it? 1. It said annually. Once a year for 7 years. Once a year for 7 years. That's what I'm doing. Okay, so type that in. Are we matching? No? You want to try it again and see? Don't put the ones in there, just avoid them, right? You don't need them. Okay, are we matching? What did I type in? Are you ready? 4,000 bracket 1 plus 0.028 bracket to a 7.
Why does the formula have the 1?
Have the 1?
Yeah.
Because it's how many times a year, but we only did a compound at the end of each year. Yeah. But I wrote it in there because eventually we're going to have compounds more. Okay. So do we have the conclusion? Because I might just ask you some basic question. Are you going to make more money with simple or compound? What's the answer? Conclusion, compound would be more. Okay, number 3 here. We're going to compare interest if we compound something semi-annually or compound something monthly. Okay, so semi-annually, how many times a year do you do something? Twice. Monthly, 12. Okay, so you invest 7,000. So A equals 7,000. 1 plus the rate, so 0.033 divided by the N. What is the N? 2. N times the time. So the 3 came from 3 years. So here's what I'm doing up at top. I do something twice a year for 3 years. So how many times do you end up doing it altogether if you do it twice a year for 3 years? So 6 compounds. Because there might be a question, just how many compounds do you do? Well, you do it 6 times. Okay, so please just type to the 6 when you're typing this at the end. And tell me if we're getting the same. Okay, this is not the answer though. Look at what I wanted. How much interest did you make? That's not your interest. This is your, what does it represent again? Final. That's how much you have in your bank account today at the end. So how much money did you make from the bank? What are you going to do? Subtract your start. So that's the interest part of it, okay? Interest means what the bank put into your account, right? Okay, now we have compound this monthly. So we're going to do the same thing except what? Instead of 2, you're going to put a 12. Lauren, did the typing go good on this last one? Yeah. Okay. So think about something. If you do it 12 times a year for 3 years, we should be doing it 36 compounds. So that's the exponent. Yeah? So then, remember again, that's a final number. Okay, so compare your rate of return. So what is the little formula I gave you yesterday? The money you made divided by the money you put in. That's kind of the idea. How much did you make divided by what you had to put into this thing? So we made 722.22 by putting in 7,000 of our own money. A 10.3% return on my investment. Okay, you always have to times it by 100 to make it into that percent. Money you made divided by money you put in. Okay, that's that understanding. How much do I get as a return on my investment? Okay, should we make a conclusion? So this had all the same criteria except for one got compounded more than the other. So what's your conclusion about number of compounds? More compounds you can do will equal more money. Okay? So there might be some basic questions like that on the test. I might just say, here's two people, who made more money? I don't want you to figure it out, just tell me who. Okay, number 4, 9,000, 3.4. Estimate the time it will take to double your money. Okay, so estimate the time to double your money. So estimate is using the rule of 72. That's the, when you hear the word estimate, use this rule of 72. So 72 divided by I. So what am I replace I with? 3.4, not the decimal part. Okay. Determine the actual time to double your money. Okay, so here's what I want to do. So, you don't need to write this out. I'm just going to write it out. Okay, so here we go. Principal, I can do 9,000 right there. 1 plus 0.034 divided by n. How many times a year do you do all this? Quarterly? 4. The exponent would be 4 times the time. That's the thing I'm trying to figure out. Then I want to double my money. So how much money do I need to replace my final with? 18,000. I saw you mouthing it. 18,000. Okay. Does anybody know how to algebraically solve for variables when they're in the exponent position? No. For you, because you can use logarithmics. So what are we going to do? Because we have these things. What should we do? How do you solve where two equations would equal each other? What do you think we would do? y1, y2, figure out the intersection. Wherever this equals this, that gets us the solution. Okay, so give me y1, y2.
As long as we don't have to do logs.
Can you make sure this exponent 4t goes in a bracket? To the bracket 4x on your calculator. And then remember that our answer we're looking for is around 21, right?
What are we supposed to do with the exponent? 4t?
Did you do that? 4x to the bracket 4x? Okay, everyone's good with that? y1, y2? Let's go to our window. X is the time. What do you think is a good time to go to? I'm going to do 30. Why did I pick 30? Because I want my answer to be close to 21, right? Because that was the estimate. And what do you think would be a good height to get to?
Maybe 18,000.
Past 18,000.
Maybe I should have thought of
So I'm going to go to 25,000. Why is the money? We already have 18,000 on this one, so yikes, right? So I'm trying to get to 18,000. Look at my money. What's my money doing? Does it grow linearly or would it curve, right? Does that make sense why it's curving? Okay, so compound interest grows like that. So where did we get to? How was our estimate?
20.47. You want an investment?
20.47 years. Ooh, that estimate thing was pretty close then. Okay, I really wish I put another question on here, so I'm just going to add this. Okay, you were 10 years old when you put this money in. Probably not a lot of 10-year-olds have $9,000, so we'll just make this up. You were 10 years old when you put it in. When will you have $72,000? When will you have $72,000? Using the we're going to use the estimate.
What does the 10 years old part have to do?
That's how old you were when you put it into the investment, into the bank.
But what does it have to do with the question?
I'm going to, I want to know how old you are at the end.
Oh, okay.
I should have rephrased that better. When will you have it? Like, how old are you going to be?
Yeah.
Okay, ready? So I'm going to draw a chart. Okay, so when you were 10 years old, how much money did you put into the bank? $9,000. Okay, it took me 21 years to double my money. How old am I right now? 21 years later.
30.
So I'm 31 years old, and I could double my money. So now I have $18,000 and I'm 31 years old.
So now when you double it again,
So I'm going to double it again. So 21 years later, I am a 52-year-old. And I now have how much money? 36,000. 21 years later, I'm 73. So this is the estimate. You're going to be 73 years old. Okay, so you might see a question like that. Should have put that in there. All right, last question. You invest this much compounded semi for 3 years. You end up with this much interest. What rate did you invest in at? Okay, so let's think about what we know. $7,600 can be my principal. Compounded semi-monthly.
so 600 years, right? Every other month.
Semi-monthly is
Twice in a month?
semi-monthly. So semi-annually was twice a year. So semi-monthly is twice a month.
24.
So 24. So that goes in place of my N. I did it 24 times every year. For 3 years. So are we okay? I'm just going to write this as a 72 exponent. I'm going to leave R, right? Because that's the thing we're trying to figure out. Okay, you got this much interest, but there's no spot for interest here. This is final. So can I use the interest to figure out my final bank account? What's your bank account going to be? Okay, does that make sense? You got to use final, principal, and interest. They all work together. They're either kind of adding or subtracting to get to places where you need to go. Okay. Okay. How many people would jump to their calculator and do a y1, y2, and just let their calculator do that? If you want, go for that. How many people would jump to algebra? You can do whatever you want right now. Okay? What kind of person are you? So I am going to do algebra on my paper so those people can see. Okay, the people that are doing your calculator, this thing you're solving for is an R. So do you understand your R number is going to be a decimal? So think about your window. Is your window something big? Because your R is under 1. Your R is a decimal. Look at what the answer is. Think about what your window would be. Make your x negative 1 to 1. Did you get it on your calculator? It is the same? Matches?